Hey everyone, and welcome. On behalf of Forge College, I am just absolutely thrilled to have you here for this capstone explainer in our Programming with Solana track. Today, we're going to master the art of planning the client interaction script. So what's our ultimate goal here? Well, it's taking all that hard work you've already put into your library configurations and translating it into a master blueprint for a highly functional client script. Because let's face it, we need a rock-solid plan before we even think about building. So let's just dive right in, shall we?
Now, if you recall our previous lesson, we spent a lot of time building what we can kind of think of as our musicians, right? These are your custom RPC wrappers, your error handling loops, and those observability hooks. But here's the thing. Without a conductor actually planning the script out, those highly skilled musicians, they're going to play wildly out of tune. And out in the Web3 environment, an out-of-tune orchestra doesn't just sound bad, it will literally drain your testnet funds right before your eyes through failed transactions. No way we want that. So we absolutely need a conductor to step in and handle the sequencing and the recovery gracefully.
To get our orchestra playing in perfect harmony, here's our engineering schematic for the day. We'll start with the orchestra conductor, then step 1, taking inventory, step 2, mapping flows, step 3, defining success, preparing for deployment, and we'll wrap it all up with the final performance.
All right, first up, the orchestra conductor, separating primitives from orchestration.
So the core mental model to grasp here is that the conductor doesn't actually play the instruments, right? They simply sequence the interactions, enforce those strict error policies, and run the acceptance checks. They're mapping the score and signaling the cues. Your musicians, on the other hand, which are your library functions, they handle the narrowly scoped execution. This includes things like idempotent operations, meaning, actions you can repeat safely without messing up the end result beyond that first application. It also includes deterministic serialization, ensuring data is packed up the exact same predictable way every single time. And honestly, keeping this orchestration completely separate from your primitive library functions is exactly what prevents brittle code. If a musician falters, or if you just need to swap out a component during rehearsal, you don't have to rewrite the entire score.
Moving right along to step 1, taking inventory. Gathering the building blocks.
Okay, before the curtain even rises, you really need to take a strict, comprehensive inventory of every single component. You've got to document your program entry points, so your instructions and your account mappings. You need your library functions locked down, which are those custom wrappers and retries we talked about. And you absolutely cannot forget your external dependencies. I'm talking about your RPC endpoints and your keypairs. Enumerating every single program ID, account key, and stable function acts as the raw foundational material for your script. Trust me, doing this up front completely prevents those nasty mid-deployment surprises.
Next up is step 2, mapping flows, timing, and sequences. So, this is where we draw out the actual circuitry and decision nodes of our script. It starts with the client trigger, moves right along to the RPC submission, then into program execution, and finally lands on the state recheck. But the really vital part to notice here is the flow between these nodes. This is exactly where our custom retry wrappers step up to catch transient network failures. Those missed cues we keep talking about. By mapping this entire sequence out in advance, we make sure that when an RPC node inevitably hiccups, and it will, the script gracefully recovers and reroutes, instead of just crashing the whole performance.
Which brings us to step 3, defining success, state and observability.
Now that we have a flow, what does a successful rehearsal actually look like? Well, we need strict acceptance criteria. A successful run means, and I quote, account X has flag Y set, the RPC latency is under 500 milliseconds, and absolutely nothing is on fire. I mean, seriously, success isn't just about the state changing on-chain. Yes, we obviously need that account flag to flip, but we also have to verify that our observability hooks are logging the right audio feeds and metrics. If the state changes, but your latency is suddenly through the roof and your logs are just screaming with silent errors, yeah, that is definitely not a successful rehearsal.
Okay, let's shift gears a bit. Preparing for deployment, environment and artifacts.
Because here's the reality. Our script cannot run in a vacuum. It needs a perfectly configured stage and, quite frankly, a dedicated cleanup crew. So we have to verify our CLI artifacts and program IDs. We need to set our pair-T-pair paths and define our cluster target, whether that's localnet, devnet, or testnet. We also need to get our observability logs and metrics fully established. And please pay special attention to this last one, creating a rollback and cleanup checklist. If a run fails, You absolutely must have a rollback plan so you don't leave messy, orphaned temporary accounts scattered all over your testnet.
All right, let's bring this entire blueprint together. The final performance, a multi-instruction token flow.
Let's see how all of this builds into a concrete multi-instruction example. In step 1, we create a temporary account using our custom create or get component. And our acceptance signal here? Very simple. The account exists and a log event fires. Moving to step 2, we deposit rent using our RPC call with retry. We check that the balance actually increases and a signature is present. Then, step 3, we actually mint the tokens using the mint2 instruction. Now right here, our retry safeguards are absolutely crucial to prevent double minting. Our success signal is that the token balance perfectly matches our intended quantity. Finally, step 4 is our cleanup function, closing the temp account to safely reclaim our lamp ports back to the pair. See? That is the conductor guiding the musicians flawlessly through the score.
Which leaves us with one final, very important question to ponder. Are your musicians ready for the conductor? As you move forward, I really want you to bring these exact planning artifacts, your inventory, your flow diagrams, your acceptance criteria, right into the next integration lesson. Because if you do, your implementation will actually focus on wiring and verification rather than retroactive fixes. Well, I want to thank you all so much for joining me for this explainer on behalf of Forge College. Be sure to head over to our website at forge.college to learn more about this subject and to explore a ton of other fascinating Web3 topics. So, go take a look at your blueprints, check your notes, and ask yourself, is your planned script truly ready for prime time? Happy building, everyone, and I'll see you next time.